हाय एवरीवन। सो बाइवेरिएट नॉर्मल डिस्ट्रीब्यूशन को कंटिन्यू करते हुए आज जो हमारे पास टॉपिक है दैट्स मार्जिनल डिस्ट्रीब्यूशन ऑफ बाइवेरिएट नॉर्मल डिस्ट्रीब्यूशन. As you are familiar with, when we have joint distribution we can find the marginal of separate distributions. If we have f of x comma y, we can find f of x as well as f of y, right? So we have bivariate normal distribution. The PDF of bivariate normal distribution is like f of x comma y is equal to 1 upon 2 pi sigma 1 sigma 2 under root 1 minus rho square e raised power minus 1 by 2 1 minus rho square, then x minus mu 1 upon sigma 1 whole square plus x minus y minus mu 2 upon sigma 2 whole square minus 2 rho x minus mu upon sigma 1 y minus mu 2 upon sigma 2, right? And and the range of x comma y is this, right? So this is the PDF of bivariate normal distribution. From here we can find f of x and f of y. I hope you must be knowing how to calculate f of x and how to take limits when we are dealing with the marginal of x, right? So f of x is equal to, that's PDF of random variable x is equal to minus infinity to infinity f of x comma y, and we take limits of dy. When we are calculating the marginal of f of x comma y, we take the limits of dy, right? And similarly, if we are calculating the marginal of y, we take the limits of dx, right? So f of x is equal to, the limits are same, minus infinity to infinity. What's f of x? As you know, let let's suppose this quantity is k. Let's suppose this whole quantity is k. So this is k e to the power minus 1 by 2 1 minus rho square x minus mu 1 upon sigma 1 square plus y minus mu 2 upon sigma 2 square minus 2 rho x minus mu 1 upon sigma 1 y minus mu 2 upon sigma 2. This is dy. See, let u is equal to y minus mu 2 upon sigma 2. We are letting that y minus mu 2 upon sigma 2 is equal to u. So what will be the dy? What will be the dy, or we can say du is equal to, we are differentiating this with respect to y, so from here 1 upon sigma 2 is constant. Differentiation of this would be dy upon sigma 2, right? So sigma 2 du is equal to dy. So the differentiation of this quantity is dy. As you know, differentiation of dy with respect to y is equal to y dy. Differentiation of this is equal to dy, as you know, right? So now f of x would be k minus infinity to infinity 1 upon e raised e raised power minus 1 upon 2 1 minus rho square 1 minus rho square x minus mu 1 upon sigma 1 whole square. And what is this? This is u square plus u square minus 2 rho u x minus mu 1 upon sigma 1. I hope you are getting this. In place of u, in place of y minus mu 2 upon sigma 2, we let this quantity, that y minus u2 divided by sigma 2 is equal to u, right? So with differentiation of dy, we have calculated that dy is equal to sigma 2 du. ठीक है? Then f of x is equal to minus infinity to infinity, minus infinity to infinity, minus infinity to infinity. See, from here sigma 2 and wait a minute, मैं आपको एक चीज़ बताता हूँ यहाँ पे क्या होगा. सी, अगर मैं इसको लिखूंगा 1/2 पाई सिग्मा 1 सिग्मा 2 1 माइनस रो स्क्वायर माइनस इन्फिनिटी टू इन्फिनिटी ई टू द पावर माइनस 1/2 1 माइनस रो स्क्वायर देन x माइनस म्यू 1 अपॉन सिग्मा 1 स्क्वायर प्लस म्यू स्क्वायर माइनस 2 रो u x माइनस म्यू 1 अपॉन सिग्मा 1 सिग्मा 2 du. दिस एंड दिस गोज, ये तो कैंसिल आउट हो जाएगा. देन f ऑफ x वुड बी 1/2 पाई सिग्मा 1 1 माइनस रो स्क्वायर माइनस इन्फिनिटी टू इन्फिनिटी e to the power this x minus mu 1 upon sigma 1 square plus mu square minus 2 rho u x minus mu 1 upon sigma 1 du, right? So from here we can write it as 1 upon 2 pi sigma 1 1 minus rho square e to the power minus 1/2 x minus mu 1 upon sigma 1 square. Then again minus infinity to infinity, we take common, this common, and this is on exponential, that's this is on exponent e raised power minus 1/2, and then similarly this 1/2 1 minus rho square mu minus rho x minus mu 1 upon sigma 1 का whole square into du, right? So let me write it again 1/2 pi sigma 1 1 minus rho square e to the power minus 1/2 x minus mu 1 upon sigma 1 का whole square, then minus infinity to infinity e to the power minus 1/2 e to the power minus 1/2 1 minus rho square, then mu minus rho x minus mu upon sigma 1 का whole square du, right? So put 1 upon under root 1 minus rho square u minus rho x minus mu 1 upon sigma 1 is equal to t. From here du will be, this term goes here, then differentiation of this is du because this is free of u, so this will be equal to 0. So du is equal to 1 under root of 1 minus rho square dt. So now the f of x becomes 1/2 pi sigma 1 e raised power minus 1/2 x minus mu 1 upon sigma 1 square, then minus infinity to infinity. See, look at this term, this becomes e raised power minus 1/2, and this is t square, this is t, so t with square, that becomes e raised power minus 1/2 t square dt. I hope you are getting me, right? So this will become 1/2 pi sigma 1 e raised power minus 1/2 x minus mu 1 upon sigma 1 square. And what is the value of this? As you may be knowing from continuous random variable, this is the CDF of normal distribution. So the area under this PDF will be under root 2 pi. If you don't know about this, just go and check the unit continuous distribution. There you will find normal distribution, then check the CDF of normal distribution, right? So this is equal to this, and are seeing that you are seeing that what will be the limits, or what will be the limits of this x, because we are having the variable x, so limit will be this, right? So this becomes 1 upon under root 2 pi, under root 2 pi, under root 2 pi, under root 2 pi sigma 1 e raised power minus 1 by 2 x minus mu upon sigma whole square, where the limits would be, we are having under root 2 pi and 2 pi, so squaring, or we can say multiply and divide both sides by under root 2 pi, under root 2 pi, we will be left with only 2 pi in denominator. So this is the PDF of normal distribution. So x follows normal mu comma sigma square, mu 1 comma sigma 1 square. Similarly, y follows normal mu 2 comma sigma 2 square. Or we, as you know, what is MGF, moment generating function? We have already done it in last lecture. So we can give this, another method. We can find the PDF by another method, that's MGF method, so this will be the elytra of the above method. So by MGF m of x comma y t1 t2, what is this? T1 mu 1 plus t2 mu 2 plus 1 half of t1 square sigma 1 square plus t2 square sigma 2 square plus 2 row t1 t2 sigma 1 sigma 2. So this is the MGF of bivariate normal distribution. Let me give you a brief concept here. If x follows some distribution, y follows some distribution, f of x comma y follows some distribution, right? So if the MGF of mx comma y is equal to e to the power tx plus ty, this is the joint MGF of x comma y. So if we need to calculate the marginal, we can put mx comma y t1 if we need the MGF of x1, or we can need the MGF of x, we can put t2 is equal to 0, so that we can get the MGF of x, राइट? यहाँ से हम क्या करेंगे, सी अगर हमारे पास m ऑफ x कमा y है, दिस इज जॉइंट MGF, तो हमें अगर मार्जिनल x का चाहिए, हम t2 की जगह वैल्यू पुट करेंगे 0, तो हमारे पास MGF ऑफ x, सिमिलरली y का भी निकल के आ गया। तो वही कंसेप्ट हम यहाँ पे यूज़ करेंगे। अगर हमें MGF ऑफ x1 मतलब x का चाहिए, तो यहाँ पे जो भी t2 होगा उस पर 0 वैल्यू पुट करेंगे, ये तो 0 बनेगा, ये भी 0 बनेगा, ये तो पूरा 0 बनेगा। सो यहाँ से क्या मिलेगा, e to the power t1 u1 plus 1 half of t1 square sigma 1 square, and this is the MGF of normal distribution. So x follows normal mu comma sigma square. ये MGF से आया, जब आपको MGF पता होगा तब आप करोगे, वरना आपको पूरा वो कैलकुलेट करना पड़ेगा। सिमिलरली mx2, तो यहाँ पे t1 को पुट करेंगे 0, t2 ये क्या बनेगा, e t2 mu 2 plus 1 half of t2 square sigma 2 square, and y follows, yeah, x2 follows normal mu 2 comma sigma 2 square. So this was all about marginal of bivariate normal distribution, marginal distribution of x and y, right? So here is a note, or we can say remark is about if x comma y follows bivariate normal mu 1 mu 2 sigma 1 square sigma 2 square rho, then marginal PDFs of x and y are also normal but converse not true. Here this is saying that if you are having bivariate normal distribution, then the marginals are normal, they will follow normal distribution. But if you are having normal distribution, this is not necessary that x and y follow bivariate normal, right? That if you are having x and y are normal, it is not necessary that their joint distribution is bivariate normal. In case of bivariate normal, if rho of x comma y is equal to 0, this will eventually say that covariance of x comma y is equal to 0. So in this case, x and y are independent. X and y are independent. This is only in case of bivariate. If we are talking about in general, if rho is equal to 0, then we can't say that x and y are independent. But if x and y are independent, then covariance of rho is equal to 0. This is true, but this the converse of this above statement is not true, right? If x and y are independent, then we can say covariance is equal to 0, rho is equal to 0 between x and y. But if covariance is equal to 0, we can't say x and y are independent in general. But in case of bivariate normal, the converse is also true. Converse is also true. Remember this, right? Remember this. Now, from bivariate normal, you can get the bivariate standard bivariate normal by putting mu is equal to 0 and sigma square is equal to 1. Then the corresponding marginal of x and y are normal standard normal, राइट मतलब मेरे कहने का मतलब है अगर आपके पास बाइवेरिएट नॉर्मल है 0 0 1 1 रो, सो यहाँ से x फॉलो करेगा नॉर्मल 0, 1 और y फॉलो करेगा नॉर्मल 0, 1. अगर ये स्टैंडर्ड बाइवेरिएट नॉर्मल है तो इनका मार्जिनल भी स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन को फॉलो करेगा, राइट? सो अब क्या करेंगे हम ना, conditional distribution or bivariate normal. Now conditional distribution. Conditional distribution of bivariate normal. As you know, if I am talking about probability of A given B, what is this probability of A intersection B divided by probability of B? B is that the event is already occurred, right? So in case of PDFs, the f of x comma y is equal to f of x y. This is joint PDF divided by f of y, and this is marginal. This is joint PDF and this is marginal of y, right? So as you know, what is joint PDF? This is bivariate normal. And what is this? So we can write it as f of x comma y is equal to 1 upon sigma 1 sigma 2, or simply we can write it as 1 upon sigma 1 sigma 2, wait a minute, 2 pi sigma 1 sigma 2 1 minus rho square e raised power minus 1 by 2 1 minus rho square x minus mu 1 upon sigma 1 plus x minus y minus mu 2 upon sigma 2 minus 2 rho x minus mu 1 upon sigma 1 x minus mu 2 y minus mu 2 upon sigma 2 divided by 1 upon under root 2 pi sigma 1 e to the power minus 1 by 2 sigma square x minus mu. This is y minus mu. This is sigma 2, sigma 2 y minus mu 2 ka whole square, right? From here when we divide this by this, we will get 1 upon sigma 1 under root 2 pi 1 minus rho square e to the power minus 1 by 2 1 minus rho square x minus mu 1 upon sigma 1 square minus 2 rho x minus mu 1 upon sigma 1 multiply y minus mu 2 upon sigma 2 plus y minus mu 2 upon sigma 2 whole square and multiply 1 minus 1 minus rho square, and this will be equal to 1 upon sigma 1 under root 2 pi 1 minus rho square e to the power minus 1 by 2 1 minus rho square sigma 1 x minus mu 1 minus rho sigma 1 sigma 2 y minus mu 2 का whole square, and this will be equal to 1 upon sigma 1 under root 2 pi 1 minus rho square e raised power minus 1 by 2 1 minus rho square sigma 1 square x minus mu 1 plus rho sigma 1 sigma 2 y minus mu 2 square. So this is the joint distribution of this. So we can say x comma y follows bivariate normal with mu 1 plus rho sigma 1 upon sigma 2 y minus mu 2 comma 1 minus rho square sigma x square. Similarly, y given x follows bivariate normal mu 2 rho sigma 2 upon sigma 1 x minus mu 1 1 minus rho square sigma y square. From here you can get expectation and variance easily. So expectation of x given y will be this term, as you may be knowing that when we are talking about x follows normal 0 comma 1, so the expectation of x will be 0. So from here expectation of x comma y is equal to this term. So this is equal to mu 1 plus rho sigma 1 sigma 2 y minus mu 2. If you are given with y is equal to 2, so you put y is equal to 2 here, and mu 1 mu 2 sigma 1 sigma 2 rho are already given in the PDF, right? So similarly expectation of y given x will be mu 2 plus rho sigma 2 upon sigma 1 x minus mu 1. This is plus here. And what's variance of x given y? That is equal to 1 minus rho square sigma y square. Variance of y given x will be 1 minus rho square sigma y square. So this is whole about conditional PDFs. You can follow the fundamental of mathematical statistics for the conditional PDF, right? So here is a numerical, that is x comma y follows bivariate normal 3 comma 1 mu 1 mu 2 sigma 1 sigma 2 square 3 by 5. So this is mu 1, this is mu 2, this is sigma 1, this is 16, this is sigma 2, this is rho, this sigma 1 square sigma 2 square. So we need to calculate their probability. This, and what will be the expectation of x given y, variance of x given y, and what will be the covariance between x comma y. We need to calculate this. So solution is, as you know, this is my conditional, this is x given y, this is simply conditional. So we calculate, firstly we calculate expectation of x given y. What is this x given y? This is expectation of x given y is equal to 1. So what's expectation of x given y? the expectation of x given y is, this is y here, sorry, this is y here, expectation of y given x, variance of y given x. So expectation of y given x would be mu 2 plus rho sigma 2 upon sigma 1 x minus mu x, right? What's my mu 2? What's my mu 2? Mu 2 is here 1, so this will be 1 plus x is equal to 7, x is equal to 7, this is already given, x is equal to 7. So 1 plus rho is 3 by 5. What is sigma 2? Sigma 2 is, this is sigma square, so sigma will be 5 and this will be 4. 7 minus 1, mu x is 3, 7 minus 3. So this 5 goes, 1 plus 3 by 4 into 4, so this will be 4. So expectation of y given x is equal to 4. Now variance of y given x, that is 1 minus rho square sigma x square. So 1 minus, what's rho is 3 by 5 square into sigma x, this is 25. So this will be 1 minus 3 3s are 9, 2 5 5s are 25 into 25. So this will be 25 minus 9, 25 minus 9, that is 16 divided by 25 into 25. This 25 goes, this is equal to 16. So variance of y given x is 16. Now covariance between x comma y, this is rho sigma x sigma y. As you know, this is 3 by 5 into 4 into 5. This goes 3 4s are 12, and this is incorrect. Why incorrect? Okay, yeah, this covariance will be 12. If rho is asking, if you are asked about rho is between minus 1 to plus 1. If rho, then this is equal to this, so this is equal to this 12. If this is 12, what is sigma x? 4 into 5, 4 5s are 20. Yeah, 3 4 3s are 4 5s are, yeah, the covariance is correct. Covariance is correct, as when we put covariance of x comma y sigma x sigma y, we will get 3 by 5. Yeah, this is correct, covariance is correct. So we need to calculate 3 given x is equal to 7. We need to calculate this. Treat this as conditional, right? So we find the expectation of x given y, right? We find the expectation of x given y, and we find the variance of x given y. So when you are calculating this, x minus mu upon sigma less than z less than t, so this will be probability z less than t, so this is equal to phi of t, right? So you are given with the standard normal table that phi of something is given there. So we will use the concept here in case of this conditional to see see as you know this is conditional, right? So यहाँ पे हम क्या करेंगे, सी probability 3 minus what is the conditional expectation, that is 4, वो तो हमने निकाला है, that is 4. 3 minus 4 divided by what is conditional variance, that is 16, so under root of 16 less than x minus 4 upon under root 16, 8 minus 4 upon under root 16. यहाँ पे आपको एक चीज़ ध्यान रखती है, इसको आपको इसके साथ कुछ नहीं करना. जब आपने कंडीशनल एक्सपेक्टेशन देन कंडीशनल वेरिएंस निकाला तो आप इस पे काम करोगे, ओनली यू विल वर्क ऑन दिस टर्म, ये आप इग्नोर कर देना, ठीक है. नाउ probability minus 1 by 4 and this will become z standard normal, this is equal to 8 minus 4 divided by 4 is 1, so this will be equal to phi of 1 minus phi of minus 1 by 4, and you know it that phi of minus x plus phi of x is equal to 1. So phi of minus x would be 1 minus phi of x. So in place of this, we will write that this is phi of 1 minus, what is this? This is 1 minus phi of 1 by 4, right? So इसको हम ऐसे लिख सकते हैं, phi of 1 plus 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 phi of, this is plus phi of, wait a minute, phi of 1 is equal to 1 minus, एक minute, sorry. So this is equal to, if this is phi of minus 1 by 4, so what will be the phi of minus 1 by 4 in terms of, if we use this expression 1 minus, so phi of 1 plus phi of 1 by 4 minus 1, check it, you will get it. This was the question. So ऐसी questions आपको देखने को मिलेंगे. Now one more question. X comma y follows bivariate normal 5, 10, 1, 25 row. Then find probability x plus y less than 16 if row is equal to 0. Now solution, what's expectation of x plus y? That is 15. What's variance of x plus y? That is 1 plus 25, and the covariance term will get vanished because row is equal to 0, so covariance is 0, right? So this is 26. Now probability of x plus y minus 15 divided by 26 under root 26 is less than 15, is less than 16 minus 15 upon under root 26. So this will be phi of 1 upon 26, under root 1 upon 26. Now the next questions that you are having in this chapter will be discussed later.